your Spring Boot API accepting bad data? Let's fix that. Essential input validation starts now. In this tutorial, we will address the critical issue of invalid data submissions. You will learn how to add the Spring Boot validation dependency, apply powerful annotations like not blank, size, and mean directly to your data entities, and use valid annotation in your REST controller to enforce these rules. We will also demonstrate how to return clear custom error message when validation fails, highlighting why this is crucial, and setting the stage for even more robust error handling solutions for your application. Let's get started. In our previous tutorial, we learned how to create a REST API CRUD application using Spring Boot. Here is an example that REST API for adding a new product. In Postman, we have this request for adding a new product. This was a post request and the URL was localhost 8080 API /products. And here is the JSON data for adding a new product. And if we send this request, it's showing a 500 internal server error. Let's check what's the problem. Let's restart the application and back to the Postman and send the request again. Now in the response, let's make response window a little bit bigger. Here in the response, we have the product that we have newly added. Here in the IDE, you can see the insert statement in the console. Let's check the database. Let me minimize this console. Open the database tool. This is our schema. Let's refresh it. Our table. This is our product table. Double click in this product table to open the data. This is our data from the MySQL database table. This item is newly added. We have just now added it using post request. Now let's go back to the Postman again. This time let's remove this name. Let's remove this name property from the JSON payload. Send the request again. Here we can see in the response our new product is added. The ID of the newly added product is 2 and the name is null. That means this null value for the name was accepted. If we check the database, let's refresh the data. Here we have this newly saved data, but this name is null. And now even we send a request with a negative price, let's update the price, provide a negative sign before this price and send the request. Here you can see our negative price is accepted. In the database, let's refresh it again. Here we have this product with negative price. This should not be allowed. The price of a product must not be negative and the name of the product should not be null. So we need to add validation. This acceptance of invalid data is a critical flaw that could corrupt your data in real application. In this video, we learn how to validate this data. Let's close the database view. For adding validation, first of all, we need to add a dependency to our pom.xml file. Open the pom.xml file. Here we have these Spring Boot starter dependencies that we have added previously in our tutorial on the Spring Boot CRUD API. Beside these, I also need another dependency specifically for validation. For that, open the web browser. Here, search for Maven Central. This is the site we are looking for, central.sonatype.com. Let's enter this site. Here in the search box, search for Spring Boot Starter Validation. From this search result, we need this one, Spring Boot Starter Validation, from the group org.springframework.boot. Click this link here. Now, as we are using Maven, make sure Apache Maven is selected from this drop-down. We need to copy this code snippet. Click this button, copy to clipboard, to copy the code snippet. Back to the IDE. In the pom.xml file, paste this dependency declaration here after the Spring Boot Starter Web dependency. Now for this Spring Boot Starter Validation dependency, we do not need this explicit version declaration because we are using the Spring Boot parent starter. It's good practice to let Spring Boot manage the version for its starter to ensure compatibility. So let's remove this version. Now we need to synchronize our Maven project, so it's download the new dependency. You can do this by right click in the pom.xml file, then Maven and synchronize project. This will load Maven changes. Our project is updated with the new validation dependency. Let's close this pom.xml file. Now that the necessary setup is done, we'll add the validation rules to our product object. Let's open our product class from model package. Here, in this product class, we will define our validation rules. This product class currently serves as our JPA entity. It's worth noting that in larger real-world project, you might use data transfer object DTOs to receive data in your controller, and you typically apply validation rule to those DTOs. However, for the simplicity of this tutorial, we will add the validation annotations directly to our product entity. Let's begin the validation rules. For the name field, I want to ensure it's not blank and has minimum length of 5 characters. To enforce that it's not blank, we'll add the not blank annotation. For its message attribute, we'll set name is required. Next, for the size constraint, we'll use size annotation. This size should be imported from Jakarta validation constraints. Here is our import statements. Here we have imported the size from Jakarta validation constraints, and similarly this not blank also imported from Jakarta validation constraints. Now for the size annotation on the name field, set the minimum size to 5, and for corresponding message it will be name needs to be at least 5 characters. Okay, now for the description field, the validation will be similar. Let's copy the two annotations not blank and size from the name field and paste them above description field. We'll update the message for not blank on description to description is required. For the size annotation, let's change the minimum length from 5 to 10 characters, and the message to description needs to be at least 10 characters. Moving to the price must not be negative. To enforce this, we'll use the mean annotation. Set its value attribute to 0, indicating that 0 is the minimum acceptable value. For the message, price cannot be negative. Finally, for the category field, we will add similar validation as our other text fields. Let's copy the validation rules from other field, from this description field, and paste them above category field. Update not blank message to category is required. For size, set the minimum size for the category name to 5 and update the message to category needs to be at least 5 characters. So with these changes, the validation rules are now added to our product class. Now we will configure the controller to validate the input data. Navigate to the product controller. In this controller class, I am searching for the post request method. This is the post mapping. This one is for adding new product. In this method, we are accepting a product object as request body. We need to add validation in this request body. For this, we need to add the valid annotation before the request body. Make sure it's imported from Jakarta validation. And also for the update operation. This is our put mapping here. Here too we are accepting a product in the request body. Let's add the valid annotation before this request body as well. For the input validation, with these changes, we are now set for input validation to be triggered. Let's start the project and see this in action. So our project has started. Open Postman. This was our previous invalid request where the name was missing and the price was negative. Let's send this request. Here in the response, we have this 400 bad request. So our validation is working at a basic level by preventing the request. If you check the IDE console, you'll see no insert statement was executed. Let's check the database. Here, no new data is saved. Let's remove the previous data we inserted before adding validation. Let's remove these existing test entries, and finally commit the changes in the database too. Now let's send a request again from the postman to save the product with invalid data. Here we have these 400 bad requests in the response with this JSON. And if you check the database, let's refresh this. We have not saved any new data. So our validation is working to prevent invalid data persistence. But here is the problem. We are getting the status code 400 bad request with a JSON response that shows the timestamp, status, error, and path. This is not very helpful for the client or a front-end developer. It would be much better if we could get the exact error message and the specific field name that is invalid. We'll do that now. Back to the IDE. Let's close this database view. In our product controller, at the end of this class, I will add an exception handler method. This method will be responsible for handling validation failures and customizing the error response. First, for the HTTP status, this handler should respond with bad request. So, add the response status annotation and set its value to HTTP status dot bad request. And then we need to specify which exception this method will handle. We'll use ExceptionHandler annotation and provide MethodArgumentNotValidException dot class as its argument. So, what's an exception handler? It's a Spring mechanism that allows us to define methods to handle specific exceptions thrown by our controller methods. Instead of letting Spring return a generic error response, we can customize the output. We are specifically targeting MethodArgumentNotValidException because this is the exception Spring automatically throws when an argument annotated with valid, like our products, fails its validation checks. Now, let's create the public method. The response in this case of validation failure will be a map. Here, the key is a string that will be the field name and the value is also string. This will hold the error message. Now, let's name the method handle validation exceptions. It accepts. Let's move to the next line for parameter. It accepts method argument not valid exception as an argument. This object will contain details about the validation failures. We need to import this map from Java util map. Here, in this method, we are going to build the response map and send it back to the client. The response will be in a JSON format, looking something like this. First, we will have this field name, like name, and then the error message, like this message, name is required. We will send this response in this format. The key will be the field name and the value will be the error message. Let's declare a variable for our errors map. And this equals new instance of hash map. Now, we are going to iterate through the exception caught in the method argument not valid exception object and build this error map. For doing this, we start with the EX object that we received as a method argument. And here we are calling getBindingResult. This getBindingResult method gives us an object that contains all the details about data binding and validation errors. From that result, we then call getAllErrors to retrieve a list of all the validation errors that occurred. Now, to process each error individually, we'll use the for each loop. This takes a lambda expression. We'll call each error object in this list as ERR. Then the arrow, and inside our loop, for each error, we want to get the name of the field that caused the validation issue. First, let's extract the field error from the error object. Field error, our name of the variable is field error. This equal error. We need to cast this with field error. Now, from this field error, we'll get the field name. We declare a string variable called field name. To get this field name, we take our current field error object and call the getField method. This will return the actual name of the input field as a string and get stored in the field name variable. And here, actually, we can combine these two lines of code into a single statement. Let me show you how. Let's comment out the previous two statements for our reference. Now, declare a new variable, string field name. To get this field name, we take our current error object. Since getAllErrors can return various type of object error and we are interested in errors tied to a specific field, we need to cast this error to a field error type. And then on this field error object, we call the getField method. This returns the actual name of the input field as a string. Now we'll get the same result as before, but with this single statement. You can use whichever style you prefer. Both are correct. Now let's get actual error message. Creating a new variable of type string named error message. This equals error.getDefaultMessage. And finally, we need to build our response map. The name of our map was errors. So errors.put. The key is our field name and the value is the error message. This completes the loop for processing each error. After the loop, we return the errors map. Here, I forgot to add a semicolon. Let me add that. Okay. Now, let's run the project and test this. In Postman, with previous invalid data, that is missing name and with negative price, let's send the request. Here, you see in the response, we still have the status code 400 bad request. But now, we have this error message in a JSON format. This is much more informative. Let's update the price. Remove the negative sign, making it valid price. Then send the request again. Now in the response, it's showing the remaining error, which is name is required. Now let's add the name. Let's say it's laptop air and update the price to $10.99 and send the request. And in the response, we have a 201 created status code, meaning we have successfully added a new product. This new item is added and here is its ID, that is 4. If you check the database, open the database tool, we need to minimize the console. Here, double click the database table. Here we have this new data, laptop air in the database. Okay, we have learned how to validate input for our REST API. But there is still problem with this current solution. If we were to only rely on the exception handler we might have in product controller. The exception handler we defined inside product controller will only work for invalid data received by that specific product controller. In real world project, you may have hundreds of controllers. If you apply this approach, then you need to add this same exception handling logic into each controller for validation purpose, which is not efficient. Let me show you an example. Let's create a new controller inside the controller package. Let's name it product details controller. Give it the REST controller annotation and a request mapping to API/product details. In this controller, I am adding a post mapping. It will be public method. Here, I will just demonstrate the validation behavior, so I don't actually save the data or perform other operations with this endpoint. So let's set return type to string. Let's name this method product details. It accepts a product object from the request body. So we'll use request body annotation, then product, and it will return that product. Initially, I thought I might return a string message, but let's have this method return the product object that it receives in the request body and return. We need to give name this product request body variable and return. Update the return statement. Here we have made a typo in the method name. Let's fix it. For validation to be triggered, add valid annotation before request body. Now back to the Postman. Let's update the URL to our new endpoint, product details, and send the request using same JSON body as before. Here it's showing a 401 not found response. This is because we have added a new controller and modified the code. So we need to restart the Spring Boot application. Now back to the Postman. Send the request again. Here we are getting this response, the product we have sent in the request. The ID is null, which is expected because we have not provided an ID, and it would normally be generated automatically upon saving to the database, which this endpoint is not doing right now. Now let's remove the name property from the request JSON to make this an invalid request and send it. Here in the response, we have a 400 bad request status, and in the response body, we are getting this generic error message from Spring instead of the structured proper error message that we have defined earlier in our product controller. So what we need to do to fix that for this controller? Let's navigate to the product controller. and copy this handle validation exception method from this controller class and paste this into our newly created product details controller. Now restart the project. Back to the Postman, send the same invalid request. So we are now getting the proper error message that we defined. But let's be realistic. Is copying this handle validation exception method into every single controller is the best approach? Imagine a large enterprise application with dozens, maybe even hundreds of controllers. Duplicating the code everywhere would lead to a lot of boilerplate, make it harder to maintain consistency, and increase the chance of errors if a change is needed. Clearly, this is not the clean, scalable solution we aim for, especially with a powerful framework like Spring Boot. The solution is a global exception handler, a single, powerful mechanism in Spring to handle validation errors consistently across our entire API without any code duplication. Want to learn how to implement this professional technique and make your error handling truly robust and application-wide? And that's exactly what we are building step by step in the next video. See you there.